So in the previous part of this module, we added the code to decode the incoming messages. And we had decoders for join message, chat message, and get users message. And they're all the messages that we can handle inside the on message processing of the Java server. So what I'd like to do now is to break this on message processing down so that we process each of these messages in a different way. So we'll remove the broadcast from this. And then inside here, in this case, we'll have a simple set of if and else. Inside here, we'll have a set of if statements that just looks at the type of message we've been sent and then processes the message based on that type. So something like if message is instance of join message, then we'll call a process message function, which we haven't written yet, passing it the message. And for this, we need to cast this to be of type join message. And then we'll have a bunch of if-else's that'll process the other messages in the same way. So we'll end up with code which looks something like this. So each message will be done slightly differently. So we need to add process message for each of these message types. So we'll just let IntelliJ do that for us. So we add one process message for join message. We'll add one process message for chat message. And we'll add one process message for get users message. So chat message here. And then this one will be get users message here. And this will be get users message here. So taking these simplest first, the simplest one to implement is chat message. When the user sends us a chat message, we want to save away that message in a list of messages, so that if the user asks us for all the messages, we have them, and we need to broadcast that message to all the listening users. So we can simply say broadcast and pass it message. And then at the top of this endpoint, we'll create a static list of message, and this will be the messages that we want to use, assuming I can spell static correctly. So this will be a new, we'll just in this case create an array list to hold these messages. And then in the process message for the chat message, we're simply going to do messages dot add message. So we save away each message that gets sent to us. So the join message processing is a little more complex, but not too much. What we'll do for the join message is create a user and save that user in a list of users. So to do that, in my sources, I'm going to create a new Java class called user. And that Java class will simply have a name field, which is going to be a private string name. And again, for this, we'll create a getter and a setter. Then back in the endpoint, we'll define a list of users that we can use. Again, that'll be similar to the message list. And then in the process message for user, we'll have a user, so user equals new user. We'll do user dot set name, which will be message dot get name. We'll do users dot add user, so we now have a list of users. And then again, we broadcast the message. So in this case, we're broadcasting out the fact that a user's joined. The client, when it receives this broadcast message, will just assume that this is a new user and display that new user within the user interface. So the final incoming message to process is the get users message. And in this case, when somebody asks us for a list of users, we're going to send out two other messages. We want to broadcast a list of users, and we're also going to broadcast a list of messages. So these are two message types that we haven't implemented yet. So we need to create a new user list message and a new chat messages message. So in our code here, we'll add a new class called user list message, and this is going to extend message. And the user list message will contain a list of users. So when we create this thing, we want to set the message type to be false. This is an outgoing message, so we have to be able to set the type, and we want to initialize it with the list of users that are passed to us. So back in the endpoint, our broadcast list of users becomes session.getBasicRemote.sendObject again. So we're sending out the list of users, and we're going to send out a new user list message, and that user list message will contain a collection of users, and that's simply on chat endpoint.users. We need to surround this with a try catch. So similarly to sending out our user list message, we need to send out our chat messages message. So again, under messages, if I create a new class called chat messages message, and again, this will extend message. And again, this will look very similar to our user list message. In here now, though, we have a list of chat messages that we're going to use. And again, back in the endpoint, as well as sending out a new user list message, we want to send out a new chat messages message. And rather than passing this the chat endpoint.users, we pass as the chat endpoint.messages. Oh, and the chat messages message expects us to be passed a list of chat messages, and we're passing in a list of messages. So we can just go and change the type, the collection here, to rather than being a list of message, to be a list of chat message. That should stop the code complaining. So we can now see this code in action. So we have an instance of Chrome running that's already connected to the server, but we haven't joined the rooms yet. And we have an instance of Firefox running that hasn't connected to the server. So if inside Chrome I type in my user's name, let's say Alice, and click on join, then Alice's name is entered. That's been sent back to me, and we can see that here. And if I go to Firefox and browse to the server, Firefox should send out a get users message, and we should get back the list of users. Sure enough, we get back Alice. If I go into Firefox and type in the name Bob and click on join, then Bob is broadcast to both. And if I go back into Chrome and type in a message such as hello Bob and click on send, then that message is sent to both browsers. And just to show that if we bring up a new browser, so I'll kill Firefox, go back and run it again, and enter the address or localhost 8080, then when we connect, we should bring back a list of users and a list of messages. And sure enough, there's the users and there's the message that's been saved on the server. So it looks like all our message decoding is now working.